So .NET Framework. So when you did Java, you had the Java runtime. Inside of that Java runtime were a series of packages that had classes and code that you could use and reuse. The .NET Framework, in a holistic perspective, is that same thing, just the Microsoft version of that. So you can think of the .NET Framework as having two pieces. You have all of your assemblies, or DLLs. That's the code that comes shipped with the framework that allows you to kind of get up and running without having to write all your code yourself. Now, what does that mean and what does that look like? Well, you've got the core, which is the runtime, those base class libraries, that chunk of code. We have actually multiple languages under .NET. You have C#, VB.NET, F#. There is a C++.NET, which is basically C++ on top of the .NET Framework compiled into what is called an intermediate runtime, or IL language. We have LINQ, which is an extension feature of .NET, and we'll get into that in later week lectures, and XAML, which is a UI designer component / language, which we'll kind of touch on at the very end of the course, but not really get a whole lot into because of the focus. So the two things I'm going to focus on with this piece is the runtime and the base class libraries. Now, if you look at the components of this diagram, and if this is hard to see, it is up on Blackboard. You should have access. You can click in there and look at this .NET 2013 universe. You'll see that we have web apps, cloud apps, services, Windows Store apps, Windows Phone apps. There are partnership platform apps. Then we have desktop apps, embedded system apps, DI and IOC containers, which are architectural components. We have data access layers, .NET extension libraries, a caching engine, and my little Java window's in the way. I can't read the last one. Security. So this is all built into the framework out of the box. So you have utility classes, you have components that allow you to bring them into your project and facilitate what you're doing without you having to invent or write a caching engine, or for you have to create a security layer, for you have to write the data access model to connect to a database. There are classes that are built into the framework or that can be downloaded third party that you can simply consume and bring into your application, and it will give you, database access as a prime example. There's a class that allows you to connect to a SQL server. There's another class that you then say, here's the command I want to run on that SQL server, and then there's a third class that facilitates actually executing that connection, grabbing the data you need, and then pulling it back into memory away from the database. So that's all built into the framework. When we talk about later about creating forms, that form is a class. That class comes with the base class libraries. It's all a component of the framework that you don't have to create. All of the controls that we interact with, those are all part of the base class libraries. You can get third-party controls, but the ones that we deal with on a regular basis, buttons, text boxes, labels, drop-down lists, are all pre-coded. Someone or a team of someone's at Microsoft coded those controls, those classes for you, and made them accessible so that you just drag them on a screen, code up what you need it to do, the event it needs to handle, and you're done. So I think I asked a question at the end of the week last week of who wrote forms or did forms in Java. And I think about half of you raised your hand. Well, all of that work essentially, with the help of Visual Studio as well, that work doesn't really exist in the .NET world because it's kind of done for you. You're given that as a gift. You simply drag a control on a form, you write up what you want that control to do in terms of like when this button is clicked, do this thing, and then you go on your way and do the more sophisticated work that may be involved in actually building an application. So this is a very high-level overview of the .NET framework. Nope. This is a more succinct complete version of the framework. And I'll zoom in and kind of walk around certain pieces so you can get a sense. Now, if you take the Web Server Application Development course, which is the next course after this, you will cover web development using .NET. So there's an entire, not just one assembly or one library, but there are multiple libraries that make up that space. So we have things like system.web.ui, system web dynamic data, system web data visualization charting, system web UI web controls, system web routing, system web MVC, system component model, data annotations, and then AJAX. The core contains things like system.numerics, system.io, system.component model, system.link, system.xaml, those two pieces I talked about earlier. The ability to build multi-threaded apps, so system.threading, system.runtime interrupt. It allows you to take your .NET app and work with older style COM components, which are basically all of the, that was the latest and greatest coding concept back in the 90s, so during Windows 95 in that period. So if you're dealing with legacy applications that you need to be able to use today, that interrupt allows you to do that. Then you get into workflow management. So if you are on a co-op where you deal with a large infrastructure organization, they're trying to build workflow and process to the things that they do. There are actually workflow components built into the framework that allow you to have your application model a workflow. So if this thing happens, then go off on this track, or if this decision is made, go off on track B, and stops and checks and all of those components. System.data also includes a fair bit of information. It's that idea of being able to connect to a database. And it's not just Microsoft products either. You can connect to MySQL, you can connect to Oracle, you can connect to NoSQL site type databases like MongoDB. You have pretty much an infinite number of connectors that you could use to connect to a database. But the infrastructure to do that is built into the framework. The communication components of the framework are system.net. So you want to have your application make a web request. There's HTTP models and classes that allow you to do that. You can do raw socket connections. So if you really want to get down and dirty and actually create a true TCP socket connection and you want to attach to a port on a computer or on a device and be able to do two-way communication with that socket, you can do that. There are, let's see what else is there. There are higher level, or actually lower level I/O components that allow you to do interfacing with things like web services. You can do interfacing with actually specific memory streams, so you can do streaming of content and data. There's a lot of options. So pretty much if you can think of a need or something you want to do, there's probably a piece within the framework that will allow you to do that. And then a majority of this class is focused on this client area. And this has to do with building those desktop applications and building command line applications. So building programs that run on a client computer or workstation. So things like doing rich media, image manipulation, forms applications, line of business type apps. All of that lives within this client kind of zone or realm. So when you think about the topics that we're going to cover in this class, we're not just covering how to build a desktop application. In the past, that's about as far as I've gotten with this class. But I'd like to really reach and stretch beyond just, here's how you build a desktop app. At one point in time, I used to give a project that was essentially come up with something you want to build. Sky's the limit. You come to me, you tell me what you want to build, I approve it, and then you have the rest of the term to build it. Most students just built basic desktop applications, which was fine. They met the requirements and it worked. I had one student who said, "You ever use TweetDeck?" I said, "Yeah, I've used TweetDeck." He goes, "I'd like to build an application like TweetDeck, but for Facebook, where I could essentially log into Facebook on my desktop and pull down multiple feeds and streams of data simultaneously." I said, "Do you have any idea how to do that?" He goes, "Nope." I said, "All right, let's do it." And he and I worked, and we came up to some pretty interesting challenges because you may know this, you may not know this, but the Facebook APIs are not designed to work on a desktop. They're designed to work in a web application. So the first challenge we had to overcome was, how do we essentially fake this application to make Facebook think that it's a web application when in fact it's a desktop app? So you have to make web browser requests to Facebook as if you were just a browser. It then is going to respond back to you, sending you back website URLs that you're supposed to connect to, and then you're supposed to present them to the user. And if you've ever logged into a website using your Facebook, you click that log into Facebook, and then it comes up with you have to approve and say that you want to allow this application to look at your Facebook profile. We had to fake all of that. We had to say, "Hey, we're trying to log into Facebook," and it says, "Okay, well, tell me your website URL." So we had to create this like micro web server on the desktop that Facebook could talk back to make all of it. It was a very interesting little project. But my goal is that I want everyone to get to that level to go, all right, how do we approach this challenge, and then how do we overcome? Because at the end of the day, all software is the same. And it's really about how creative can you be and what tools do you have at your disposal. So I really want to get into processing web requests, consuming JSON and XML web services, building multi-threaded applications, building database-connected applications. If anyone is actually interested, I'd be open to allowing them to come up with a custom project for the term that goes above and beyond kind of the default term project. If you don't feel like being that creative, that's okay. That's why I give you a project. So I always like to put that out there. I'm always interested to see who are the creatives. So what questions can I answer with regard to the .NET framework at this point? Is there anything you're curious about? Can you do this? Can you do that? Kind of an idea. Yeah?
Can you do anything like with mobile on it, like make apps that work on Android?
So with the help of a third party called Xamarin, you can actually create iOS, Android, and Windows Phone apps all in C#.
With the help of what, sorry?
What was that?
With the help of what you said?
Xamarin. It's Xamiran. You basically write it all in C#, and their philosophy is you write your business logic once in C#, you deploy it out to all three platforms. So basically anything that has to do with connecting to web services, connecting to databases, handling authentication, all of those utility classes, all of those models that you would use. You use the exact same code on all three platforms. And then the only piece that you customize is the UI. You still write it in C#. You can build them in Visual Studio if you have the right license. But if you've ever looked at an iPhone app versus an Android app versus a Windows Phone app, they are just inherently different because they are different platforms. You can build them the same, but they don't ever feel quite native. So their philosophy is you can build maybe the interfaces for how those UIs work, and you'll understand this a bit more when we get into the actual form design. But the idea is when someone clicks a button, it may always call the same code, but that button looks different on an iPhone than it does on an Android than it does on a Windows Phone. But the idea is that you can get somewhere between 75 and 90% of your code the same across and hit all three platforms. So people always say, well, you should learn Objective-C or you should learn Java so you can do Android apps. But with .NET, you actually have the flexibility of running .NET code on all three platforms. And kind of along those same lines, Microsoft announced, it's been in the last 6 months, they're actually working to retool the .NET framework. They are open sourcing somewhere between 70 to 80% of it. And they are building, with the help of some third parties, one of those being Xamarin, full compatible runtime environments for Windows, Mac, and Linux. So Microsoft has finally stepped up and kind of gotten into the game. So the ability to write a C# app and run it on a Linux machine or a Mac is actually more reasonable than people give them credit. And it'll be even more reasonable probably in the next year. So. Okay, any other questions? All right, if they come up, you can ask.